Hello, it's Ediford, and in this video I'm going to be explaining the filter function in Python. To go over it real quick, the filter function allows you to grab an interval. This is the thing that you want to filter stuff out of, and you pass it through a function which removes the stuff that you don't want, and in return you get an filter object which then you can make into a tuple, list, whatever. So as an analogy, imagine you have a whole bunch of garbage or trash or whatever you call it, and you want metal. But obviously in garbage there's other stuff such as plastic. What the filter does is it removes everything that isn't metal. So there will be no plastic and you just get metal in that interval. So hopefully that explanation made sense. I'm going to get into the coding aspect of it. And as always, I'll start relatively simple before getting into the more complex stuff. Over here, we have grades, which is a 2D list. And just before we get into the filter function, I'm just going to quickly give some context of how this works. For every grade, which is every list, in this 2D list, we will pass it through this function. And if it is true, it returns true. If it is false, it returns false, based on if the first index is greater than or equal to 40. That's how you do it without the filter function. And if I run the code, it works just fine. You can then build onto this so you can get the list and everything. But you came here for the filter. The filter function does the exact same thing. It passes grades as a 2D list. In is passing, which is a function. And if it returns true, it passes on to this list. And when we print it out, we get Mike and Anna as in a 2D list. Both of them are lists and stored within a list. The same thing works with lambda. Lambda takes in an argument. If the first index of that argument is greater than or equal to 40, it adds on to the list. So when we print it out, we get a 2D list of Anna and Mike. Often you might be dealing with empty stuff, so things that don't have a value. Filter function removes it by using none. If the value is none, for example, this is completely empty list, that means the value is none, so it kicks out. And if I run the code, you can see there is no empty list here. But you might want to remove any empty lists and also keep the this original function. And for that, there's a couple ways to do it. I'm going to go over the more simple way first. Towards the end of the video, I'm going to go over the more complex way, but that requires a whole nother import stuff. The simple way to do it is just to use filter twice. So we have filter over here, which removes all the ones that have a value. And then we have another filter, which works just as the one before that one, where it removes anything that is smaller than 40. The filter object here, that's because we're printing X. We are printing passing grades here, and passing grades applied is passing to X, so to that filter object. So we get the exact same result of Anna and Mike having 40 and 70, but no one else. You might want to use more than one value in our lists. So in this case, I'm using 3, but it works if we're going to use 4 or 5 or whatever. And in that case, it's the same thing as before. You just compare both values at the same time or separately. So you already know this bit. Grade 2 is lower than or equal to E. That's because in Python, the alphabet has like a value attached to it. That A is low, Z is high. So if the second index is lower than or equal to E, it gets passed through. And if the first index is bigger than or equal to 40, it also gets passed through, which means you need both for it to work. Jeffrey has a U, so he can't get passed through. Bob, even though he has an E, he doesn't have 40, so he can't get passed through. It works exactly the same as before. The filter function can also be used to filter out different types of values. Before, we've been checking how strong it was or comparing it if it's equal to this or whatnot. Here we are seeing if it is a string or not. It can work if it is an integer, float, boolean, and what have you. How it works is we have the first function. This checks the temperature just like before. The second function checks if it is a string. This uses isInstance. I will have a video on this in the future, but just to give a quick rundown, isInstance checks if the value it is received, so X0, Moscow, Canberra, London, McMurdo, if that is a string, which as you can see it is, then it returns true. This is not a string, that is an integer, so it will return false. And as such, it will be filtered out. You can see there is no 0, 0. You can also see McMurdo isn't here because it has -30 and we want stuff that is 0 or higher. Same thing works with the lambda function. We take in an argument and we see if that argument is a string or not, and if it is bigger than or equal to 0 from temperatures, because temperatures retains the string and the integer. Below that is another way you can filter stuff out by the length. I'm going back to passing grades instead of passing temps. And if the length is bigger than 1, it gets passed through. If it's not, so if it's an empty string, for example, it doesn't. You can also apply this to other stuff. If there's like a minimum word amount, you could just cut off, for example. If it's like below the minimum, it doesn't get counted, or whatever problem you may have. If I run the code, you can see this bit is exactly the same, and Anna Mike is exactly the same too. For the more complicated stuff, this is using functools. It is an inbuilt Python module, and we are using partial. We have a function to check if it is divisible by a number. In this case, 2. This number can change, but I'm just going to keep it constant just for teaching you. If you want to change it, then you would have to make this into an input. So there'll be like a user input over here that you can then add on, so it changes based on what the user says, for example. But we have two numbers. It checks if x is divisible by y, and if it is divisible, it means that it will return. If it is divisible, the result will be 0, and it would return true. Partial makes it so that you can apply one item or one value to a function, but not the other. We need 2 arguments. Filter only accepts 1. By adding partial, we are essentially locking in or freezing y as 2. We are making it so the y equals that. And once y equals 2, we store that as a variable. So when we use the filter function, we only apply this variable and not this function. So that when we iterate over numbers, we see, okay, 1 is divisible by 2. That locks y as 2. So it will be 1 goes over in the x column, 2 goes into the y, and 1 is not divisible by 2, so it gets filtered out. The end result is 2, 4, 6, 8, 10. There's a way to do it without using the partial function. That's by making a custom wrapper. What this does is, the filter function executes this function. This function executes this function. So in effect, this function is being executed, however, not directly by filter. Filter calls this, and this sends 2 in the y position, and whatever numbers is, it sends that as the x position. Then we get a value, true or false. That makes this true or false, and that determines if it gets kicked out or if it stays in. For example, if you have 2 different lists that you need to compare and filter out, you could also use a zip in that situation, just to zip them up together and then pass them through the filter. However, sometimes that's not always possible, or one list is longer than the other, for example. The filter function it really shines when you apply it with other stuff such as zip, map, and I haven't made the video yet, but reduce. So when you learn how to use filter, try and mix it up with those stuff. If you do want to learn about the other stuff, the zip, map, and so on, I have videos on them just in the description or at the end card. Click on it and I'll see you there.